Hello everyone, I am Dr. VRAO. I hope you are all fine and doing well. In the last video, that is lecture 23, salt hydrolysis part 2, we had gone through the hydrolysis of strong acid, hydrolysis of salt derived from strong acid and strong base, and hydrolysis of salt derived from weak acid and strong base, and hydrolysis of salt derived from strong acid and weak base. In continuation to the last video, in this video I shall make an attempt to explain the salt hydrolysis of salt derived from weak acid and weak base. Okay, so hydrolysis of salt derived from weak acid plus weak base. Okay, unlike the other salt hydrolysis, that is unlike the hydrolysis of strong acid strong base, unlike the hydrolysis of salt derived from strong acid strong base, weak acid strong base or strong acid weak base, hydrolysis of salt derived from weak acid and weak base is unique. It has a special characteristics when compared with the other salt hydrolysis. Okay, so let us see what are that special characteristics, what is that speciality in the hydrolysis of salt derived from strong acid weak acid and weak base. Okay, so let me give one example for salt derived from weak acid and weak base. So that is the best example for salt derived from weak acid and weak base is ammonium acetate, because this is derived from weak acid acetic acid plus weak base NH4OH, right? And already I told you that I had given the definition and explanation for hydrolysis, salt hydrolysis. Salt, we know the definition of salt, and hydrolysis, we know the definition of hydrolysis. Hydrolysis is nothing but adding water to salt. Salt hydrolysis is adding water to salt. Here hydrolysis of salt derived from weak acid and weak base. So the salt is CH3COONH4. Here the salt is ammonium acetate. We are adding, hydrolysis means adding water. So we are adding water. When we add water to ammonium acetate, that becomes aqueous ammonium acetate solution, which upon ionization it gives CH3COO minus plus NH4 plus. Okay, CH3COO minus, acetic acid is a weak acid, its conjugate base is strong base. Ammonium hydroxide is a weak base, its conjugate acid is strong acid. Okay, so in the earlier hydrolysis of salt derived from strong acid strong base, weak acid strong base, strong acid weak base, the nature of the resulting solution, that is when we add water to salt, that results salt solution, and the nature of the salt solution is based on whichever is strong, that is in the combination of acid base, whichever is strong, then that strongness is ascribed to a resulting solution. But here when we add water to ammonium acetate, that results ammonium acetate salt solution, ammonium acetate salt solution. But the nature of the ammonium acetate solution depends on acid dissociation constant Ka and base dissociation constant Kb. But in the earlier cases, that is in the prior salt hydrolysis, nature of the solution depends on, or nature of the resulting solution is whichever is strong in the salt combination, whichever is strong, that strongness is ascribed to the resulting salt solution. That strongness is the nature. For example, if the strong base is, if the salt is formed from strong acid weak base, then the resulting solution is acidic. If the salt is formed from the weak acid and strong base, and the resulting solution is basic solution. But here when we add water to ammonium acetate solution, that results ammonium acetate salt solution. But the nature of the resulting salt solution depends on Ka of acid dissociation constant Ka and base dissociation constant Kb. Why? Because here the formed, here the acid is weak acid and the base is weak base. Okay. So if Ka is greater than Kb, that is acid dissociation constant is greater than base dissociation constant, then salt solution is acidic salt, that is resulting solution nature is acidic in nature. If Kb is greater than Ka, then the resulting salt solution nature is basic in nature, that the resulting solution nature is basic in nature. If Ka is equal to Kb, if Ka equal to Kb, that is the acid dissociation constant is equal to base dissociation constant, then the resulting solution is neutral, that is pH is 7. If the solution is acidic, pH is less than 7. And if the solution is basic, pH is greater than 7. Okay. So, but I told you that unlike the other salt hydrolysis, the hydrolysis of salt derived from weak acid and weak base has special characteristics. What are the special characteristics? The nature of the salt solution, the nature of the resulting salt solution depends on Ka and Kb values. But in the earlier cases, whichever is strong, in the combination of salt, whichever is strong, that strongness is ascribed to resulting salt solution. But here is that does not happens in the case of weak acid, salt derived from weak acid and weak base. Let us see, let us derive the ultimately when we add water to ammonium acetate solution, that results salt solution. When we concerns with salt solution, we need to address the pH of that solution or pOH of the solution, depending on the nature of the resulting solution. Okay. So it is customary to find out the pH of the resulting solution. So let us derivation, let us do the derivation to calculate the pH of the resulting solution. Okay. So CH3COO NH4, upon this ionization it gives CH3COO minus and NH4 plus ions, and these ions are these ions are present in the water, that is NH4 plus undergoes hydrolysis, that is water interacts with the anion and water interacts with the cation, that is the hydrolysis. Okay. So, already I told you the definition of hydrolysis. Because in the hydrolysis phenomena, water interacts with the cation or anion or both of a salt, resulting the formation of H plus ions or OH minus ions or both the ions is called salt hydrolysis. So, here the water interacts with the cation as well as anion, that forms acetic acid plus NH4OH, weak acid and weak base. Weak acid and weak base. So, this undergoes salt hydrolysis. Okay. So, the salt hydrolysis constant KH is given by concentration of acetic acid CH3COOH and concentration of NH4OH by concentration of CH3COO minus into concentration of NH4 plus. This is the hydrolysis constant KH. Okay. And we know the acid, let us write the acid dissociation constant. Acid dissociation constant is Ka is given by, acid dissociation constant Ka is given by CH3COO minus into concentration of H plus by concentration of acetic acid. This is the acid dissociation constant. And base dissociation constant Kb is given by concentration of NH4 plus concentration of OH minus by concentration of NH4OH. Okay. So, I shall take the ratio of Kw. We know that ionic product of water Kw is equal to concentration of H plus into concentration of OH minus. It is a product of H plus and OH minus ions. I shall take the ratio, that is Kw by Ka into Kb. Okay, that is concentration of H plus into concentration of OH minus Ka. So, acid dissociation constant Ka, which on the denominator undergoes reverted, this denominator is reverted, that is CH3COOH by CH3COO minus into concentration of H plus and Kb. This denominator is also reverted NH4OH by concentration of NH4 plus into concentration of OH minus. This OH minus are getting cancelled. OH minus H plus ions are getting cancelled. Okay. So, that gives CH3COOH, NH4OH, CH3CO minus, NH4 plus. That is nothing but hydrolysis constant. That is nothing but hydrolysis constant. So, Kw by Ka into Kb, that is equal to Kh. Okay. So, whereas in the case of other salt hydrolysis, Kh is equal to Kw by Ka if the acid is weak acid. Kh is equal to Kw by Kb if the base is weak base in the salt combination, right. So, this is another different characteristic of the hydrolysis of salt derived from weak acid and weak base. Okay. So, now let us see let us calculate the equilibrium concentration. CH3COO minus plus NH4 plus H2O gives rise to CH3COOH plus NH4 plus NH4OH. Okay. So, initial concentration of the acetate ion is also is C, and NH4 plus ion concentration is C. Okay. And before the equilibrium is attained, acetic acid concentration 0 and ammonium hydroxide concentration is 0, right. And after the whenever the equilibrium is attained, C, that is already I told you that degree of hydrolysis is a ratio of total, that is the fraction of total salt that has undergone hydrolysis. Okay. So, some fraction of hydrolysis salt undergoes hydrolysis, that much amount is decreased from the initial concentration, and that much amount is decreased from initial concentration, that is represented by CH, and that much concentration of acetic acid and that much concentration of ammonium hydroxide is formed. So, therefore, we can get the hydrolysis constant KH is equal to concentration of acetic acid is CH, and concentration of NH4OH is CH, and the concentration of acetate ion is it can be written as C into 1 minus H, and concentration of NH4 plus it can be written as C into 1 minus H. Okay. The next step C are cancelled. So, in the next step H square by 1 minus H whole square. So, KH is equal to H square by 1 minus H square. If this is H is degree of hydrolysis, H is degree of hydrolysis. So, if the extent of degree of hydrolysis is less than 1, then we can write 1 minus H is equal to 1. Then KH is equal to H square, and H is equal to root KH. Okay. This is the another different characteristic of hydrolysis of salt derived from weak acid and weak base. Here, unlike the earlier hydrolysis in the strong acid weak base or weak acid strong base hydrolysis, degree of hydrolysis depends on concentration, that is, on dilution degree of hydrolysis increases. In the hydrolysis of salt derived from strong acid weak base and weak acid strong base, degree of hydrolysis increases on dilution, that is, on dilution degree of hydrolysis increases, whereas in this case degree of hydrolysis is independent on concentration. This is the one most very important characteristic of this salt hydrolysis. So, degree of hydrolysis is independent on concentration, right. So, H is equal to root KH. Okay. So, whatever the derivation is, our ultimate theme is to determine the pH, of the resulting solution, So, if you want to derive the equation for pH, we have to know the concentration of H plus ions. So, I shall take the acid dissociation. I shall take the acid dissociation, because why I am taking acid dissociation, because acid upon dissociation that gives H plus ions. From that H plus ions we can get the concentration of H plus ions. Okay. So, acid dissociation Ka is equal to concentration of CH3COO minus into concentration of H plus by concentration of acetic acid CH3COOH. Okay. The concentration of acetic acid at equilibrium is C into acetate ion is C into 1 minus H by concentration of H plus ions. This is to be determined, and concentration of acetic acid is CH. Okay. Next, in the CC are getting cancelled, and 1 minus H, if H is less than 1, then 1 minus H is equal to 1. Therefore, it can be transformed as concentration of H plus ions by H. So, Ka is equal to H, and concentration of H plus ions is equal to Ka into H. Okay. So, this is the concentration of H plus ions, from which we can calculate the pH of the solution. Okay. So, Ka, what is H? What is H? H is root KH. So, instead of H we can write root KH. So, Ka into what is KH? KH is equal to Kw by Ka into Kb. Kw by Ka into Kb. Okay. In the next step we can write it as write this equation as concentration of H plus ions is equal to, we can write this equation for the sake of my convenience, it can be written as Ka square into Kw by Ka Kb. In the next step Ka square Ka, it cancelled one time, Kw into Ka by Kb. Okay. So, concentration of H plus ions is equal to root of Kw into Ka by Kb. From this we can write this when we are applying logarithm, and after that when we multiply the whole equation with the negative sign, we get the equation that is pH is equal to 1 by 2 pKw plus 1 by 2 pKa minus 1 by 2 pKb. Okay, 1 by 2 pKw, that can be written as 7, because pKw value is 4 or 14. So, 14 by 2, that is 7. So, 7 plus 1 by 2 pKa minus 1 by 2 pKb. This is pH. So, pH of the solution, resulting solution is this is. So, from this we can calculate the pOH. So, pOH is equal to 7 minus 1 by 2 pKa plus 1 by 2 pKb. Okay. We can get the pOH value by subtracting pH from 14. Then we get the negative sign for 1 by 2 pKa and positive sign for 1 by 2 pKb. So, this is the equation for pH of the resulting solution when we add water to salt derived from weak acid and weak base. But the resulting solution nature depends on Ka and Kb values. If Ka is greater than Kb, then the solution is acidic, then the pH is less than 7. Okay, if Kb is greater than Ka, then that is resulting solution is basic and pH is greater than 7. If Ka equal to Kb, then resulting solution is neutral and pH is equal to 7. Okay. So, this gives the pH of the solution. Okay, I shall okay. So this gives the pH of the solution. Okay, you please keep these two equations in your mind. You please keep these two equations. Okay, you please keep this. You please keep these two equations in your mind. Okay, so this is about salt hydrolysis of hydrolysis of salt derived from weak acid and weak base. Okay, I repeat, already I told you, hydrolysis of salt derived from weak acid and weak base, it has different characteristics. Unlike the other salt hydrolysis, it has different characteristics. That what are the different characteristics? In this, degree of hydrolysis is independent on concentration, and the hydrolysis constant is Kw by Ka into Kb. Okay, and the resulting salt solution depends on the Ka value and Kb value, that is acid dissociation constant and base dissociation constants. Okay, so I hope you all understood this long derivation. In the next video, I shall come up with a summary of all the 4 types of hydrolysis, and then we shall go to solving problems. We shall go for problem solving in the next video. Okay, in the next video, before we are solving the problems, we shall sum up all the pH equations of 4 types of salt hydrolysis. Thank you for watching.